everyone, and welcome to part 2 of our motion activate all the things with a PIR sensor. Last time we started with LEDs and we created a variety of patterns that are motion activated. So today we are going to look at servos. I have my PIR sensor right here. I already have it connected and the connections are really simple. It's just 3: power, signal, and ground. So when it detects a difference in infrared radiation walking by this Fresnel lens here, a high signal will come down this wire and into the Arduino. And then we can do with that information whatever we want. Most of these sensors have your time delay and your sensitivity. This adjusts for distance, so it can detect typically from 3 to 7 meters, 9 to 21 feet. Here's your time delay, and if you set it all the way counterclockwise like I have it, it stays high for the shortest amount of time. It's about like 3-ish seconds, and if you turn it all the way clockwise, then it'll stay on for about 3-ish minutes. It depends on your sensor. And then finally, a lot of people overlook this feature right here, which is our jumper. And it can be in 2 positions. Right now, it's in the L position, meaning single trigger. So if I have this set for, say, 2 minutes and I walk by, it'll trigger, it'll go high for 2 minutes. During those 2 minutes, I can do a whole song and dance and it's gonna lock out. It's not gonna read anything. After the 2 minutes, it'll reset and then we're ready to song and dance again. If you put it in the H position, and it's just a matter of like pulling this little thing out and then just kind of repositioning it. H position is repeat trigger. So that means, say we have it set for around 2-ish minutes. I walk by, the 2-minute counter starts and it stays high. I walk by again, wherever it was in that counter, another 2 minutes gets added. And another, until it's totally not sensing motion for 2 minutes and it'll go back to low. So it really depends on your project, what you're trying to accomplish, where to put these jumpers. I always like to try both and heck, see what works best. Let's get this guy connected here. And if you don't remember or are not sure, these things usually pop open: VCC, signal, and ground. Because this requires so very little power, I'm going to hook this up to the 5-volt of the Arduino board. And I'm just going to, I guess I should use the power rail, but it's so convenient right here. And as Bob Ross says, everybody needs a little friend. A wire, clouds, birds, trees, they all need friends. The signal wire, I'm going to put in pin 12. I think that's where we had it the last time. So we're just going to keep it there. Here I have ye old micro servo. If you are only powering one, you can go ahead and just hook it up to your board. I always go the separate power route because inevitably I always start a project and it has a tendency of getting bigger and bigger and bigger. And then I got to move wires around and things like that. So I'm going to already anticipate that this project is going to get bigger. So I'm connecting the ground and the power to the breadboard here, and the signal wire I'm going to put into, you can choose any pin. I'm going to choose pin 9. Now, if you're going to use the servo library in the Arduino code, you can connect it to any pin. It doesn't have to be a PWM pin with the squigglies, the pulse width modulation pin. Now, if you're not going to use the servo library, then yes, definitely connect your servo to one of these PWM pins. So he's all connected up. And finally, we are just going to add the power. When connecting external power, you always want to make sure that all your components share a common ground going to the Arduino. Say this wasn't here, your servo would not work. All right. To the code, everybody. First thing I like to do is to define my pins. I kind of just stick with the beginner-friendly int for integer. The PIR sensor, I'll just call it PIR pin, and that's hooked up to pin 12. That's the one thing I remembered for the night. We can add the servo stuff in later. Let's just check the PIR. We need a way to read the pin and have a variable to store whether it's high or low. So I'm going to call it motion status. I think that's what we called it last time, motion status. And I'm going to set that to 0 at first, because a lot of times when you turn on or you upload the code to the Arduino, that PIR sensor is calibrating. So it'll just falsely go off. So it's important that if you have stuff connected to it, like we had a silly string shooter, that it just doesn't accidentally go off. Let's create another variable where we'll track the state change. And I'm going to get into more details about this later on. We kind of went into a lot of depth with this in the other tutorial. So you can always follow that first and then jump back, over here, join us. Let's move on to the setup. And one of the first things I like to do or don't like to do, because I usually don't do it, I just wing it a lot of the times, but it's a good idea to set up your serial monitor. It's almost like if you don't set it up, then your code is just going to bomb, but if you do set it up, then it's like, they love to make you spend hours trying to find out what's going on. So we have our serial begin, and let's set up our pin modes. So we have to tell the Arduino how you want that pin to act. So the PIR pin is connected to pin 12, and we want that to be an input because that PIR sensor is going to be sending information, inputting it into the Arduino, and we're going to do stuff with that information. And you'll notice here, the pin mode is whatever pin is you're talking about and whether or not you want it to be an input or an output. You can hard code the pins. I don't like to, because inevitably you're always going to have to move stuff around as you add. So that's one of the reasons I like to put all my pins as variables. If I have to move it to pin 10, I have only one place to change it versus everything else. In the loop, what is the first thing we want to do? We want to read that motion sensor because we want to know what's going on. Like, should we activate things or not? So let's get the motion status. And we do that by digital reading the PIR pin. So we're going to know if it's high or low. After that, if the motion status is equal to high, what do we want to happen? Well, we're not going to activate the servo just yet. We just want some kind of message that says, hey, the motion sensor has gone off. For reading and tracking motion change, I like to use a motion state. So that way you just know once when it goes from low to high and then from high to low. So only when the change happens, not like the entire time that it's high. So in order to get that to happen, if the PIR state, and remember we made a variable for that, is low, which it is. So up here, we set our PIR, I called it PIR status, we'll call it PIR state to 0, which is low. And so when it comes down here, if the motion is high, well, we had already previously set it to low. So we need to toggle this now to high. And it doesn't mean that it's toggling the PIR sensor to high because it's already reading high. That is toggling our variable, which is we're going to use later on to control motion and all that. So we're going to toggle that to high. But before we do that, before I forget, let's serial print the fact that motion has been detected. And then we're going to take that PIR state and we are actually going to set it to high. All right, so we covered everything that if the PIR sensor sends out a high signal, but what if it sends out a low signal? Or else, if the signal is low, what do we want to happen? Well, we want to print that the motion has ended. So we're going to do kind of the same thing where if the PIR state is equal to high, because before it was high, now it has gone low. So we need to update our state change label. But before we do that, let's get the serial monitor thing out of the way. Let's do the print line. Okay, so motion ended. Oop. All right, and at this point, we want to toggle our state change indicator to low, so it matches what's going on with the pin. Oh, and another important thing in the setup, we talked about sensors needing to calibrate. So I always like to add a delay just to kind of pause everything to give it time. Now for a PIR sensor, a good delay is anywhere from 30 seconds to a minute. Now I don't want us waiting around for it to, calibrate every time we want to run examples, but to help you guys remember, we'll just put in a second. So we're going to upload the code. You know the rule. Everybody cringe, side eye, squint. Oh, it's hanging. Oh, okay, when it hangs, it's like, oh no, it's going to turn red arrows. All right, so I'm going to pop up the serial monitor and I'm going to back up slowly. Oh, it detected. So that is it calibrating right now. And so that's why you want to set it for that 30 seconds minimum. Okay, so you see it only prints the one time. And I have it set to the 3-ish second delay. So sometimes I get a little too, antsy with the motion. So we have our PIR sensor working correctly. Now let's tie in the servo and have it do some kind of action. Let's go servo pin, and where did I put it? Pin 9, right? We're just going to go for it, pin 9. Oh, and when you're doing a servo, very important, we got to add the servo library. Let's include a library, and we're going to go to servo, and up pops the code for us. Now, somewhere in here, maybe I'll kind of go over here, we have to create a special name for our servo where we're going to use this name to refer to things. So I am going to call it, and you see it turns color, so it's ready for that name. You can call it anything you want. So since this is like a haunted house attraction, I'm going to call it Scary Servo. Ooh. So that's the name that we are going to reference from now on going through the code. We also want to set up our servo. So our servo is connected to pin 9, but the Arduino doesn't know that. And yes, we did specify it up here, but for the library, it wants to know where this whole thing is. So we are going to put it servo. We're going to attach it, or ours is called Scary Servo. And we are going to attach it to pin 9, but instead of hard coding it, I'm going to go servo pin that we had set up above. Just like we have a delay, it's a good idea to start our servo zeroed out, or whatever starting position you want to do your servo. So I'm going to go scary servo dot write, and let's write it to angle 0. So everything is zeroed out as we start. We give a little time for the motion sensor to kind of calibrate. And let's go here. Where do we put this code to make this servo move? There's 2 places where you can put it. So one place is here, and this is your option 1 to activate things, or you can put it down here, which is your option 2 to activate things. We're going to go through a couple examples, and you're going to see exactly the differences it makes, whether you put your movements in this very first option, where so long as the pin is high, the movement will keep repeating itself over and over again. Now, if you know Arduino, it goes down the code super fast and then loops back up and then loops back up. So here, if you're blinking an LED, it will continue blinking until it reads low. Now, what if you want to only blink the LED like twice? Well, it's just going to keep repeating that blink, so it's more difficult to do. So let's start with the place where 90% of the people put their code, which is here. And then we'll take out option 2, and we'll deal with option 2 later. And so let's activate the servo. So if the motion status is high, what do we want to do? Well, we want this scary servo to turn to 90 degrees. Say it's like a jaw of a scary skeleton, so when it turns to 90 degrees, it goes. And here you can connect a sound, like a scream or a laugh or something like that, and the jaw opens to 90 degrees. Here we're going to skip to the else. So what if there's no motion? What do we want to happen? And here it's the same thing. Here we have option 1 for adding motion, or you can add it within this if statement, which is your option 2. So let's stick with option 1, just like we did up at the top. And what we're going to do is take Scary Servo, and we're going to close the jaw. So it's going to go back to 0. I'm going to upload it. All right, everybody, get ready. I can't believe we're not. Oh, I said this the last time. I said, I can't believe it's like uploading with no problems. And then it just got jacked up in the end. We're like looking for brackets, and it was like a manhunt for the brackets. Good. So we have like our nice, scary skeleton laughter. Let's do a servo sweep. Do we need to set up any more variables? Ooh, one for position. So we can track the position of the angle of the servo. So We'll call it angle ooh. So when you see something light up, it means that it's usually a keyword to do something. So when I'm setting up a variable and I see something light up, I pick something else. We'll call it position. So I'm going to call it POS for short. So the position, let's start the servo at 0. I like to kind of zero everything out. And we're still working with scary servo. And I don't think there's anything here for us to do. So let's get into this loop business. And let's stick with option 1. So where this thing is here, we're going to go ahead and get rid of that and do a sweeping type of motion. If the motion is high, how do we sweep? Now we can write code like you saw, scary servo dot right 0 degrees, scary servo dot right 1 degree. 2 degrees. What if we want to go to 180? That's 180 lines of code. I don't have time for that. A for loop is great for any time you have to do a repetitive motion, blinking a LED a certain number of times, or lighting 10 LEDs sequentially. Same thing for position. If we need to move to a certain number of positions, it'll help us count. For, and we're referring to the position is equal to 0. So the first clause is what's your starting point? We're going to start our position at 0. And then we want to move it to position 180. We're going to go the full way. So long as the position is equal to, or less than or equal to 80, what do we want to do? Well, we want to continue adding to that position. Whoop. And this is just fancy for, we kind of went through this the last time, position plus 1. So that's all. This is just kind of a shorthand for writing something like this. So how are we going to accomplish this motion? We're going to take our scary servo and we're going to write it by the position. And we're going to give it a delay of 7 seconds. So that way it kind of moves pretty quickly here. So if you've never worked with a for loop, what is this doing? It's taking our initial position here. It's going to take it up to 180 of an increment of 1 at a time. So it's going to write whatever the position is and do it every 7 milliseconds. So it'll start at 0. It'll write position 0. Then it's going to go back up here and say, okay, is 0 less than or equal to 180? It is. All right. So we're going to add 1 to it. All right. So increase it by 1 and take 7 milliseconds to do that. And it's going to go up again. And this is ignored. It goes to here. Is 1 less than or equal to 180? Why, certainly. So it's going to add another 1, making it 2. And it's going to keep doing that and doing that until it tries to go to 181. And it's going to say, is 181 less than or equal to 180? It is not. So it's going to jump out of this whole thing and go on to the next thing. So let's write that next thing. So at some point, the servo now is at 180. We need to bring this servo back down to 0. So it does a full sweep like that. So to do that, it's basically taking the code and we're starting at position 180 now, because that's kind of like where we ended. And how do we want to modify it? So long as the position is greater than or equal to 0, what do we want to do? We want to take that position and we want to subtract 1. And again, that's fancy for position equals position minus 1. And how are we going to do that? We're going to do it very much in the same way. So we're going to take our scary servo and write the position. And we also want to take 7 milliseconds per increment. You know the rule. People, I'm not going to say anything because I'm going to jinx it. If you're real close, it doesn't sense all that well. So I'm trying to stretch my arm. There we go. If I stretch my arm out of range. We have it set to the shortest time. What happens when I start to increase the time interval? There we go. And a little goes a long way. Like all of a sudden you're stuck in like the time delay of doom. So I'm going to move this back and you can see. See how it's going back and forth? If you wanted just one sweep, well, so long as that pin is high, because we have our block of code in that section, it just keeps checking so quickly. And it's like, oh, wait, it's still high. It's still high. It's still high. So repeat, repeat, repeat. Say for your project, you only want that sweep to happen one time. Well, option one is to turn that little knob to the time delay that magically gets your animation. It just syncs up with your animation. That's a lot of trial and error. The way I prefer to do it is to use the state change variable. So we're going to go back up here, and here it's going to read the pin. And if the motion status is high, rather than put this block of code here, I'm just going to take this, cut and paste. And this is where like the problems always start, when you start cutting and pasting things. And here, I want to put it here. And I will tell you why. The wire is reading high. So the Arduino knows that the wire is bringing in a high. Well, previously, we knew that it was low because there was no motion. So our state toggle is set to low, and it's going to print motion detected. So let's go ahead and turn our toggle to high. This is a singular motion. So now it's going to carry out this line of code and carry out this line of code. So it'll do it one time because we're only toggling it one time. And so long as this is high, this will stay toggled to high one time. So what happens when we want no motion? What's the no motion that we want? Technically, we can leave this here. So long as it reads low, it'll keep re-executing this over and over again. Like set it to 0, set it to 0, set it to 0. For good measure and for consistency, I'm going to put this down here as well. And basically, in the else, that means that that wire is reading low, which means it switched from high to low. Let's take our state, which is high, and let's switch it to low, a singular action. And so it'll write one time that to 0 before looping back and taking another reading of our PIR pin. So let's see if that works better. And that is working as expected. We expect it to turn once because we have the lowest setting. That's all it's got time for, is one turn. What happens if we are to increase the time setting? All right, it just went off. And look, it only turned the one time. It was locked in motion detected for a while because we turned up that time delay. So it's like locking out for longer, but that servo only turned the one time, which is what we want. What if you have like a jaw that needs to create different articulations? So now you have to like animate a whole sequence. Instead of the sweep, which is all this code over here, and I'm hoping I'm removing the right amount of brackets. Say motion is detected. What do we want this like skeleton to do? Scary servo dot right. We'll make him go to 90 degrees. You know, he's going to say something. And we're going to hold it there for maybe 300 milliseconds. And then we are going to go to 0. And we're going to hold that for, I'm just going random here, folks, 100 milliseconds. And then maybe we'll pick a third position. He'll go to 180. So I imagine this is a recording that you're trying to time your servo to. Now, of course, there's much easier ways to tie servos to audio, but that's for another workshop. We're going to pretend that the phrase is very short. So you can manually, kind of do this. All right. Yep. Say we were to move this entire block of code to right there, what would happen is if the time delay, say we set it to a 2-minute time delay, that sequence would repeat, and you only want the skeleton to say, welcome victims, like one time. You don't want to like scare them away. I had a blast. We've covered motion activated LEDs, now servos. So the next is going to be motors and then an MP3 player. And then finally, we're going to put all this together and orchestrate Misfit Toys type of animatronic. This is shot live. So there's probably things that I forgot to mention, and I'm going to watch this back and go, Oh man. So there will be a tutorial link in the description that you can follow along. It's going to have all of the code examples that we have done so you can copy and paste, modify to your whim. And of course, go back onto the community and post it. So I invite you to join the community. Link for that is below. Share your projects. I love to see them. And of course, we have our community Zoom builds every week. And this is a chance where I bust out my projects. You guys bust out your projects, and it's via Zoom. So we can see each other face to face, talk to each other, kind of show where we're at, where we're getting stuck, and kind of use that team mentality to help us along. So until next time, guys, bye.